Hello, my name is Stacy. I will be your instructor for this course. This course aims to demonstrate how to use InSysBio ecosystem and in particular IRT to speed up and facilitate model development and subsequent modeling. To do this, in the framework of subsequent lessons, a theoretical part and practical tasks will be given, the final result of which will be a QSP model that describes the depletion of neutrophils during sirolimus treatment. Sirolimus is a human monoclonal antibody medication against the interleukin-6 receptor. Sirolimus is used for the treatment of moderately to severely active rheumatoid arthritis in people who have not responded to or don't tolerate more conventional treatment. But it has side effects. The Monarch trial suggested a significantly higher incidence of neutropenia in patients who used sirolimus compared to patients treated with adalimumab. However, infection rates were similar between both groups. Neutropenia is an abnormally low concentration of neutrophils. People with neutropenia are more susceptible to bacterial infections, and without prompt medical attention, the condition may become life-threatening. Neutropenia resulted from sirolimus treatment is explained in terms of changes in ability of neutrophils to homogenate. One of the main sirolimus neutropenia-associated mechanisms is changing the ability of neutrophils to homogenate. In physiology, homogenation refers to the migration of white blood cells to the endothelium during blood flow and is relevant to the process of inflammation. So, the hypothesis says that binding of monoclonal antibody to interleukin-6 receptor leads to increase in neutrophils homogenation. For the hypothesis assessment, we will use InSysBio's tool, IRT, and HETA. Let's find out what IRT is. IRT is a quantitative system pharmacology platform of immune system and tool for development of QSP and mechanistic models related to immune response. You can use IRT submodel as a base for your project, but also IRT is convenient for use as information source. Ordinary differential equation describes a key cell, active substances, and surface molecules of the human immune system as a dynamic variable. Rate laws are described in accordance with the mass action law. All equations are derived from available experimental data. Regulatory effects of cytokines and other model place effects are also taken into. Parameters of the model are identified for healthy volunteers using the public domain data. Now the platform contains the following types of submodels: cell passport, cytokine production passport, and last but not least, immunological synapse passport. Cell passports contain the information about all important immune cells. There is a list of cytokines that affect immune cells and have their own passports. Immunological synapse passport shows interface between antigen-presenting cell and immune cells. I will talk about IRT in the next lesson, but if you can't wait to start practicing, you can visit IRT site via the link right now.